Good afternoon. Today's lesson 1-7 is on adding and subtracting numbers in scientific notation. Okay, the sponge or entrance ticket or whatever you want to call it, warm up, the top part of it is the wrong one, but the bottom part of it really ties into today's lesson in a realistic way. Okay, so Bob won $5.2 million in the lottery and Tajay won $2.8 million. How much more did Bob win? Okay, so our learning target today has to do with adding and subtracting, and the key words how much more are telling us to subtract. So 5.2 million minus 2.8 million. Okay, well, even though those numbers aren't written out with all the digits, it's the word million instead of writing out the digits, we can still subtract and get an answer because they both say million. So 5.2 minus 2.8 is 2.4 million. Okay? Then our next problem is the population of the Earth is nearly 7 billion people. The population of New York City is 8.4 million people. So wait a minute, this one says billion, this one says million. How many people don't live in New York City? So here again, it's a subtraction problem. We're going to have 7 billion take away 8.4 million. Now, this problem is not as straightforward as Bob and Tajay's problem because Bob and Tajay were both millions. We could just subtract the 5.2 and the 2.8, got our answer. This is 7 billion, this is 8.4 million. They're not the same size of number. So just subtracting those wouldn't work. In fact, even if we tried, 7 take away 8.4 would be a negative number, and that doesn't even make sense. So if we really wanted to find the answer to this question, we actually would have to just write it all out with 7 in the billions place minus. Now 8.4 million, the 8, so millions place, and then 3 digits, and then 3 digits. Okay, the 8 would go in the millions place. The 4 would be the next value, and then we'd fill in the rest with zeros. Okay, then I could find my answer, but I can't in a straightforward way like I did in the first problem. Well, what does this have to do with scientific notation? Well, if we're going to add or subtract in scientific notation, if our times 10 exponents match, then we can apply this little shortcut of just subtracting or adding the numbers out in front. If the exponents on the tens don't match, that's like having two different size numbers, and we can't really do our shortcut of adding or subtracting. We have to convert the numbers out into regular numbers and then subtract and so on. Okay, so that's kind of the gist of today's lesson. Alright, so let's talk about the shortcut first. So if the exponents are the same, so if you take a look at these problems right here, that's a -2 and that's a -2. This is a 3, this is a 3. This is a 4, this is a 4. That's a 6, that's a 6. Okay, when they're all the same, I can just keep that. So times 10 to the -2 would just stay in this problem. Times 10 to the 4th would just stay. Times 10 to the 3rd and times 10 to the 6th, because we're not changing units. Okay? And all I have to do mathematically is add or subtract the numbers in front of the times 10, and we're keeping the same exponent. Okay? So that means 2.5 plus 3.4 is 5.9, and then that would be my answer. And 3.75 take away 2.5 is 1.25. And that would be my answer. Okay, so great little shortcut. And it works sometimes. It works when our exponents match. Down here in these next two problems, we're going to run into a small problem. Okay? The small problem is this. If I add 4.8 and 8.5, I get 13.3. Okay, that doesn't feel wrong. It doesn't feel wrong. That does indeed add up to be 13.3, and we're keeping the exponent because they match. However, scientific notation officially cannot have a double-digit number in front of the exponent, or in front of the decimal, excuse me. So this decimal can't stay here to be official, correct scientific notation. I'd have to move it to be a single-digit number, 1.33. But if I move the exponent, or move the decimal, I also have to change the exponent. If I move it to the left, I have to go up by 1. So that's one little setback to following the shortcut when the exponents match is sometimes when you're adding, you get a number greater than 9 in front of the decimal. So if it's a 2-digit number in front of the decimal, you have to adjust the decimal and adjust your exponent. And that's kind of a pain to do sometimes. So I'll give you other strategies to use besides this. All right. And here's another problem with a similar issue. All right. 5.9 take away 5.4 is 0.5. So it looks like scientific notation, but it's not correct scientific notation because I can't have a 0 as the number in front of the decimal. It has to be 1 through 9, any number 1 through 9. So that means I need to move this decimal over to here so that it can be 5 times 10. But again, I can't just move a decimal without changing the exponent. So when I moved that decimal to the right, I have to decrease my exponent by 1. You might be thinking to yourself, gosh, I'm never going to remember to do that. Okay. So this strategy, when the exponents are the same, you can use that strategy. But if you're afraid that, these two problems right here are going to crop up and you're not going to get it right, let me give you another strategy. Plus, sometimes the exponents are different. And if the exponents are different, you really don't have a shortcut. You're just going to have to convert each number to standard notation or standard form. Okay, so that means if I was doing the first one, here's my decimal. I'd move it 5 times, once around the 8, and then 1, 2, 3, 4 more times. That's 5 total moves. Place holding zeros. Plus 6 decimal moves, 1, 2, 3, 4, 5, 6. Okay, then you would have to add those two things together on your calculator. And you would get 2, 9, 1, 2, 3, 4, 5. 2,900,000. Okay, so I've converted to standard notation. Then I either add or subtract depending on what the problem said. However, this is not the answer we're looking for on your homework tonight. If a problem is given to you in scientific notation, it should probably be answered in scientific notation, and that is in fact what we're looking for. So we need to convert back. So I'm going to need to put that decimal in front of the 9, between the 2 and the 9. And so for a final answer, I'd write 2.9 times 10 to the 1, 2, 3, 4, 5, 6th power. Okay, let's do one with a negative exponent. 2.4 times 10 to the negative 2 power. So I'd move the decimal over 2 times, 0.024 plus, negative exponents mean make decimals, move the decimal to the left 1, 2, 3 times, 0.0037, and add those together. .0277. Then convert back to scientific notation. So I'd put a decimal after the 2 times 10, old decimal, new decimal, there's 2 digits in there, -2. Okay. Over to this problem over here. 1, 2, 3, 4, 5. Minus, move this decimal over 1, 2, 3, 4. Okay, so 4 decimal moves, 5 decimal moves. Fill in zeros to fill up the space. So 5, 1, 4 zeros minus 7, 2, 3 zeros. And I get 438,000. And then for final answer, putting my decimal here. So 4.38 times 10 to the 5th power. Okay. Sometimes both your numbers aren't written in scientific notation anyway, and you really don't have a choice. You have to convert this number right here to regular standard notation. So invisible decimal, if it's a whole number, it's not 5 point something, it's just 5. Remember, there's an invisible decimal at the end. So 1, 2, 3, 4, 5, 6 decimal moves. All of them end up being zeros. So 5 million minus, we don't have to convert that, that's already there. And we get 493,800. New decimal after the 4. So 4.938 times 10 to the 1, 2, 3, 4, 5, 6th power. Okay. Some of you are bound to figure out on your own that, hey, if I type everything into the calculator, I can skip writing out all this work. So if you have a calculator, I show this to you in case you don't have a calculator at home, okay? Or your calculator does not do exponents. If you have a simple calculator at home to do the adding and subtracting, that would be fine. But some of you may not have a calculator that's a scientific one that does exponents. But if you do, let's look at some homework problems and I'll show you calculator-wise what you can do. Okay, alrighty. So we can type in on your calculator exactly what you see. 3.49 times 10 caret 3, okay, plus 2.7 times 10 caret 4. And on my calculator screen it shows 30,490. So that saved me from converting this scientific notation, and then typing them in to add together. I can type the whole thing in. But remember, I need to answer in scientific notation. So I need to put my decimal after the 3. I have to include this 0 on my answer line because it is between non-zero digits. So it's not a 0, that's an ending 0 that I can cut off. 1, 2, 3, 4 digits. So times 10 to the 4th power. Okay? What I'm seeing a lot of today in class is students that are making calculator typos. Specifically, they are typing all of their signs as multiplies or all of their signs as adds or subtract. Okay? So keep in mind that the sign in the middle is not a multiply, it's an add or subtract, and that the signs in front of the tens are multiplies. The calculator method only works as well as how carefully you type. So before you hit enter, slow down, look through what you typed, and make sure that all the signs are correct and everything is typed in correctly. Okay? Let's look at number 5 on your homework. So number 5, if you're going to type it all into the calculator, you would type in exactly what you see here. 2.1 times 10. To make the exponent of -5, you hit the caret key first, then the negative key, and 5. If you type the subtract key or you put the negative and then the caret, it will give you a syntax error. Then plus 2.6 times 10 caret -5. And my calculator reads out 0.000047. It also puts a leading 0 out in front, but you don't get marked off for leaving that leading 0 out. So that's not the scientific notation. That's not our final answer. We put a new decimal after the 4, 4.7, and how many digits are there from our old decimal to our new one? Well, there's 5. But because we're working with a decimal value, a very tiny decimal in the value, our exponent is negative. Let's look at a couple homework word problems. Okay, the distance from the Earth to the Moon is 2.389 times 10 to the 5th miles. If a space shuttle travels to the moon and back, how far did it travel? Okay, so remember this assignment is about adding and subtracting scientific notation. So if we picture what's going on, we've got the Earth, we've got the moon. We're going to the moon at 2.389 times 10 to the 5th. And we're returning. That's also 2.389 times 10 to the 5th. It's the same distance. So if we're talking about total distance to the moon and back, the context clues in the word problems to the moon and back helps us realize we're going to add. What are we adding? The 2.389 times 10 to the 5th, and we're adding it to itself. So on your homework, you should be writing down what you're adding and subtracting, showing your teachers how you're setting up the problem. So then I can type it into the calculator. I can use any of the strategies that you learn in class. And your calculator is going to spit out a number of 477 0.800. However, not done, because the directions are scientific notation. So I need to put a decimal after the 4. 4.778, cut off your ending zeros, times 10 to the 1, 2, 3, 4 fifth power. Okay. I hope this has been a helpful video, and I'll see you tomorrow.